Guys, welcome back to my channel. My name is Alam. So today we will start confusion matrix, which is not so confusing, and we will just see how confusion matrix works. So let's start. So what is confusion matrix and why you need it? So confusion matrix is basically we check the performance of the model, like how model is performing, whether we have an error or not. So in that case, we use a confusion matrix, and it is in a matrix form, that is 2 cross 2 in a matrix form. And we needed to check the accuracy of the model. Then we have a precision. Then we have a recall, and then for F1 score. So this is the main logic behind a confusion matrix. So here it is a classification measurement of for machine learning classification problem output. That is a measurement and extremely useful for recall, precision, and accuracy. So we basically dealing with the model's performance. So here you can see. So we have actual values. We have a TP, that is true positive, then false positive, then false negative, and then we have true negative. So these are four parameters, and we will learn these four parameters. Okay, so let's start. So here we have a true positive, okay, and the true negative. These two first we will understand these two things. So true positive means that our model predict the value positive, okay, but actually it is positive. Okay, so what happened is that in this case our model predict the value is positive, but actually the value is also positive, so that is true positive. So if we can give example, like a woman is pregnant, but actually she is also pregnant, so that is true positive. Another one is true negative. True negative means that our model predict negative value, but and actually it is negative. Just like man can never be pregnant, and just like I will say a man is not pregnant. So model predict that man is not pregnant, and but actually man can never be pregnant. That is true negative. So you understand the difference between true positive and a true negative. So false positive means our model predict the value positive. Actually, it is false. Actually, it is negative. Okay. So A means actually. So what happened is that we prediction is positive. Our model predict positive. Actually, it is negative. Okay. Just like a man is pregnant. Just like a man is pregnant, but actually man can never be pregnant. That is our false positive. Here, here false negative means this is a type 2 error. So false negative is basically what we have is that if you our model predict negative, right? Our and it is false, but actually it is positive. Okay, so our model predict it is negative, but actually it is positive. Just like a woman is not pregnant, just like a woman is not pregnant, but actually she is pregnant. That is our false negative. And this type 1 and type 2 error, if you see this type 1 and type 2 error, these out of these two, type 2 error consider as the most dangerous is dangerous. Okay, type 2 error is not is most dangerous error. Because see, if a person he has not he doesn't have cancer, but actually he has a cancer, same logic apply. Think about it, that a person our a patient is we our model predict that a patient is having a not disease, there's no disease. But what happen if actually the patient have a disease, and disease can may anything happen, but model predicts nothing happen, but actually it has happened. So what happen is that doctor will what happen is that in that case a doctor will be think that okay, model predict this person has no disease, so no problem, but actually the man is suffering from some disease. So we can't detect that error. That's why it is called it type 2 error is little bit dangerous. So, okay, so I hope you got some idea about type 1 and type 2 error. So let's move on to next slide. So these are our parameters of confusion matrix. One is accuracy. So accuracy is basically a kind of average, we can say. Okay, so it take all correct values divided by total number of values. So basically it's a kind of average. Then again we have a precision. Precision is basically tell us that how accurate or precise our model predict the positive value and how many of them are actual positive. That is our precision. So we have a true positive is formula is true positive divided by true positive plus false positive. And second one is called recall. Recall is basically what if I give the example like say a father who had been given a son a birthday gift for the last 10 years. So one day father asked his son, so son, tell me, do you remember all the birthday gifts which I have been given you for the last 10 years? And if the son reply, he recollect or he just remember how many 10 birthday gifts he has got for the last 10 years. So what happened is that if he recall 7 correct out of 10, so the recall will be 70%. Okay, so recall you got the with the help of example. So this is the way we used to predict our model. And this four parameter, and another one is we have another one parameter that is called this is called F1 FF measure. This F1 score is basically a balance between precision and recall. So it is a harmonic progression, and it tells that between difference between precision and recall. If precision will increase, so recall will decrease, or recall will increase, then precision will decrease. So what is the exact balance between precision and recall? That is called F1 score. So I hope you guys understood about all the parameters of accuracy, precision, recall, and F1 score. So thank you very much.